Now, just like we did in the previous video, let's try to derive how we get the second case. Here, we are going to derive the second case, where the solution is this. As you can see, x power m1 is common in both of these terms, so it can be factored out. But for now, we'll focus on how we can derive the second term. We already know that the first solution of the equation is y1 is equal to x power m. But since this is second-order differential equation, we should get two solutions. For the second solution, we'll use the known method, this one. We already have the value of y1 is equal to x power m, which can be substituted directly. But first, we need to find the value of p of x. P of x is the coefficient of the first derivative here, but the equation should be in the standard form. This means that the coefficient of the second derivative should be equal to 1. To do that, we are going to be dividing the entire equation with ax squared. So, dividing with ax squared on either side, we get this as a coefficient of the first derivative, which is equal to p of x. So the value of p of x is equal to, cancelling this with this, we are left with this. Now you can see that we will have to substitute this value of p of x and integrate it here as well. So we're going to integrate this separately. Let's do it here. Since we are integrating with respect to x, we can factor out b divided by a from integral. So we're going to be left with this. And we already know that the integration of 1 divided by x is ln x. So our final answer is going to be b divided by a ln x. Now, we are going to be substituting p of x here, and the y1 is equal to x power m here and here. Now, using the logarithmic identity, we know that e power ln x power k is equal to x power k. So this exponent and this logarithm is going to cancel out, leaving behind this only. Similarly, we are going to cancel out e from here and ln from here, taking this to the power. To find the value of 2m1 here, we are going to use quadratic formula on this auxiliary equation. The quadratic formula is now you can see in the auxiliary equation, the value of b is equal to b minus a. So we will substitute it in this equation. Now we are dealing with the case where m1 is equal to m2, meaning the roots are real and equal. We also know that the discriminant tells us about the nature of the roots. If the discriminant is greater than 0, then the roots are real and distinct. If the roots are real and equal, then the discriminant is equal to 0. And if the roots are complex conjugates, then the discriminant is going to be less than 0. So we will be substituting 0 at the place of b squared minus 4ac in this equation. Hence, we are going to be left with this value of m. Since we are trying to find the value of 2m1, we are going to be taking 2 to the other side of the equation and make it the subject. Now, we are going to be substituting it at the place of 2m1 in the original equation. Let's simplify this equation further. Now we already know that when the variables with the same basis are going to be multiplied, their powers are going to be added. So using that property, I'm going to be breaking down the denominator. Now you can see that this and this is going to cancel out, leaving behind 1 divided by x only. And we know that the integration of 1 divided by x is going to be ln x. So to write our final answer, I'm going to be doing this. This is going to be our final answer. And for the case 2, where the roots are being repeated, you're going to be writing its general solution using this equation. We already know that the value of y1 is x to the power of m, and the value of y2 is this. Hence, it is giving us our general solution for the case 2.